Now I believe we're recording. Thank you for reminding me. Remind me earlier next time.
You're welcome.
Okay, so this is the JUnit test, the first part of the lesson, the first of 3 parts in the lesson. Make sure you use the Maven template so that you get the proper structure over here to the left. But this is a JUnit test. JUnit is a very popular unit test system, and it's used a lot. This is we're using JUnit 4, 4.12. JUnit 5 is out, and there's quite a few changes, and but I'm still using 4 most of the time. And in fact, this is the first of the 8 tests that you will write right here, so you can see it. We annotate a test with the ampersand test, and you can put a parentheses and this expected equals supported operation exception dot class. What that does is that's what you're expecting, and if you don't get an unsupported operation class, the test will fail. Okay, so then you write a method, and it has to be public, have a void return, and you can call the test whatever you want. It has to be unique. This method has to be unique within the program. In this case, we're creating a list of integers, and we're using the list.of and creating a list this way. This is one of the things that parts 3 and 4 talk about, how to create. These are immutable or unmodifiable data structures, lists, sets, and maps, which these tests cover. And this creates a list with those values, but you'll notice that this add, if you can tell, it has a warning on it that's immutable object is modified. So IntelliJ is telling us that there's something wrong here. Okay, and and that's what actually is going to cause the unsupported operation exception, because when you attempt to add another element to this list, you will get an unsupported operation exception. So that test right there will be successful. And in fact, I've already run it down here, but I'll get to that in a moment. And the second test that I've put here is not one of the last 7 tests, but I wanted to show you what a normal test looks like, one that doesn't have the expected on it. And this one I call test list 2, and I couldn't make it work with this list stuff, but here I created an integer array events and put the same values in the array, and then I use an assert equals method, and that's in the org JUnit.assert class, and that's the you import it statically, by the way. This will be red, and you'll alt enter, and it'll give you import static class, and IntelliJ will put that there. And basically this says that I expect the response 3, and the what we're doing, I'm referencing the 0, 1, 2 entry in this list, and 0, 1, 2 is the 3. So in fact, the ints subscript by 2 is 3, and those are equal, so this pass will fail. Will pass. And if I you run it by clicking this the class, or you can run each individual test, okay, or you can run all of the tests by clicking that little circle on the class name, and there it ran. And you don't see a lot if it passed, but it shows you that test list 2 is green, it passed, and test list of, which is the first method, it passed. And, you know, it does these kind of, I think, in parallel, so they don't come out in the maybe the same order that they're listed. Doesn't matter. But as long as they're green, they passed, and that shows that they all passed. And it also, right here, it says tests passed 2 of 2 tests, and shows a green check mark. And if any of them fail, you can rerun them, I think, by this symbol right here that's right under the green. Rerun failed test, see? But since they all pass, that is grayed out. So this is a JUnit test class, and here are 2 unit tests. And the way that we ordinarily use unit tests is we write the test first. That's how test-driven development works. We write the test first, and it references, it's going to reference something in your program up here in the source. So the package structure in both the source area and the test area have to be the same. So if you have an edu.dccd package up here, you got to have an edu.dccd test package down here. And the idea is that you write a test and it won't compile because it references something up here in the source area. So what you do then is you go and write as little code as you can in your program that this tests, so that the test will compile. And then you run the test. And if the test passes, that's great. If it doesn't pass, then you go and fix your code so that the test does pass. Then you write another test, and then you write some more code. And then you write another test, and then you write some more code. And that's called test-driven development. And when you implement this program in production, you save both of course, the source programs for future modifications, but you also save the tests, because the next person who comes along and modifies these programs in this project already have some test methods that they can run to make sure that they didn't break anything. So these unit tests are very helpful when you're writing code, and then when you come back and modify the code later to verify that you didn't break anything. Okay, so there are 8 unit tests that you're supposed to write, and this first one is the first one. If we jump back here to here, see there's 8 unit tests, and the first one is a JUnit test that expects an unsupported operation exception when you add an int to a list of ints. And notice you do use the list of. The next one is very similar. It's a set of. So it's not going to be too difficult, because you can take the first one and modify it and use set of and try to add an element to that set, and it won't it'll give you that unsupported operation. And then you're going to use a map of, and a map of is interesting. And in fact, we'll just how about if we spend a little time? What else y'all got to do this evening, right? Public void test map of, and this is going to give us a we say expected equals unsupported operation exception. Okay, now why? Oh, dot class. You got to put dot class on there. Okay, so now we're going to write this this test. And what I want to show you is how you do that map, and we'll have a string, and hey, we'll use two strings. Okay, and we'll call this capitals equals map dot of, and then you have to give it key and value pairs, but you do that with a, I think, with a map dot entry. And I'm going to say Texas and comma Austin. No, that's not right.
Does entry have to be right after of?
Maybe so. Is that what I told you, Ivan?
That's what I have it written down as in mine. Oh no, like without the parenthesis.
I don't think so.
You can turn it on, Sissy. I'm muted.
Well, I can hear you.
Oh. So maybe I'm not muted.
Maybe you're not muted. Let's Java 10 map. By the way, I think if you go out to the, I told you so, if you go out to the Oracle site right now, you probably will not find Java 10 anymore. Java 11 is the official release, and Java 8 is still supported, and it's out there, but so you can download 8, and I'm sorry, 8 and 11. You won't find 10. So if you don't have 10, ask me. I think I have a copy of it. Okay. Entry. Well, maybe you don't put entry there. Whoops. You just put the key and the value like that. Now, I think what I was thinking about is that you also can do this. You can do entry or is it map.entry Texas. Oh, I already have Texas Austin. And then come over here. No, that's not the right format. Okay.
I think the first one has to be of entries. Like map of entries at the top.
Oh. Well.
Can I borrow Ivan's brain?
Well, he's been working ahead. There we go.
I'm just repeating what he sent me earlier today.
Yeah, he's already been working on this and been asking me questions. So that's right. Now, what did I tell you down here?
I'm not sure why that's wrong.
Method call expected. Oh, maybe I have to put another one. Oklahoma, comma, OKC. And if we can put a, come down here and put a brace and parentheses. Oops, no, that's not going to work, is it? All right. Y'all just hang on. Since I know you can't see my other monitor, I'm going over here and click on this and
That's
test.
cheating.
Uh-huh. Yeah, it is. I admit it. Okay, test map of entries, map string, state capital is equal, map dot of entries, parentheses, just entry. Okay, so come back over here and we, I think, can take the map off. And also make it a little e. There we go. Yeah. Map of entries. What have we got? I got this. Here's the. Oh, that was not what I wanted to bring up. Come on, back over here. Can't have that. List. Let's see. Map string capitals equals map dot of entries parentheses entry. Texas. They don't. That's not right. Oh, there's no brace. That's the problem. Get rid of the brace down here. Okay. And here, the semicolon. And
You removed the parenthesis, not the brace, at the bottom.
oh, thank you. They're a little hard to tell a difference, aren't they? And well, oh yeah, this is supposed to be here. There it is. There's how you do set up a map of entries. Okay. So and of course yeah, you can, well, we'll just go ahead. We want to say test map of, and no, we don't. We say, yeah, test map of dot add. That's not right. We have to apply capitals dot put, and okay, and notice that this is got a IntelliJ is telling us that that's not working. And now trying to rerun our tests, and now it's going to show we have 3 tests down here, and they should pass. Instantiating tests. There we go. Okay, so there's the test map of. So there's how you do the same thing with a map. If I had my code here, it would could have done it a lot quicker, but I had to redo it. I had to cheat and go look at my code. Okay, so that's how you write unit tests. You'll be writing 8 of them. This is one of them. Yeah, and I just gave you another. This third one, test map of, is one of the items. So the first and third one you can use. So you got 2 of them. And now we're going to talk about any questions about the tests?
No.
How do we name them? Just 1 through 8?
You can.
Okay.
Usually you give them some kind of meaningful name like test map of or test list of, but it doesn't matter what you call it. They're going to put that down here. Okay. Now I am not going to show you optional and funny time zone, but I will show you what it looks like when you run it. Show you what output I'm expecting out of this. I'm expecting you to print an offset, the zone ID, and time header, and it's and the Pacific Marquesas Islands, I guess it is. The offset is 9.5 hours, and it's 3:04 p.m. because it's 7:34 here. So, and in the American St. John's, that's kind of interesting. It's 2.5 hours off, and it's 10:04 p.m. Newfoundland is 2.5 hours off, and so forth. But there's a bunch of time zones, see, that don't are not exactly the same. They're not like 9 hours off, or we're 6 hours. We're UTC, Universal Time Coordinate, or whatever, +6. Except right now we're in daylight savings time, so it's +5. -5. I'm sorry, -5. And when we first weekend in November, when we go back to standard time, we'll be at -6. But these are locations that are like 30 minutes off or 45 minutes off the normal time zone entry. And don't worry about I put a timer on this program. Let's go back to my notes, because I gave you some notes on this. Okay. Drag this back over here. Let me close that, and so this doesn't mean an awful lot to you to read it, but and maybe look up the Java 10 time package, and you'll create a now instance. And is it instance or instant? I think it's instant. So I think the class is actually instant. INSTANT. And the class is actually now. So you say instant.now, and that gives you the current time. And you print and then you go about with formatting the time and time zone. Trying to. And did I do that? Yeah. Here's that time. This line is where you format the current time. with all the different pieces, and probably should be some spacing in here. But this is the date, and then the time entry is 1934 13.56, and I guess this is seconds and milliseconds. And here's the time zone offset that I was talking about. We're -5, and our time zone ID is America/Chicago. So that's the first thing you print. And so then I say use the zone ID class that's in the time package, and you use get available zone IDs. And that's a method name. And then you create a stream, which is of strings, by the way. And then you do a map function, and you use a method reference of zone ID : of. So that converts these strings to a zone ID entries. And then for each zone ID, you retrieve the offset. What is this? Yeah, you retrieve the offset, and then you return the total seconds and take the modulus of 3600. Modulus is that percent symbol, and that's 3600 is how many seconds there are per hour, and not equal to 0. And so that's all in that map entry. And then the next thing you're going to do is I think there's more out here. Yeah, let me get that where you can read it. You use this sorted. This is all in a stream now of stream functions. So you're going to use the sorted operation on the stream now, and in parentheses you use comparing int, and inside that you say zone IZ and a lambda expression on the zone date time class equal to the current dot with zone same instant of that zone ID. And that's how you sort this stream. And then for each entry out of the sort, you print the offset, the zone ID, and format the local time zone time. And like I say, that probably doesn't mean an awful lot to you right now, but as you look at the time package and read the section of the book, hopefully this will tell you just about exactly how to do it. Okay? And I am not going to show you any code because other than the output, but that pretty much tells you how to go about it. And I'll post this this list out there, these notes. And then the third part of this is the use of optional. And you are to create a list of students using a list of method of about 5 students, and then write about that doesn't make sense. Write a find student method that returns an optional of student type. Actually, student is a class, so that should be capitalized. Instead of returning a student, it's going to return an optional of student. And then you print the result, and you're going to call this find student method with 2 students, one of which you found, which is in that list of 5, and one that's not found. So you have to handle the optional that contains something, and you got to get the student out of the optional, and the one that's not, you have to figure out optional is empty or something like that. This is not a big program either, but until you've read up on it, this probably doesn't make a lot of sense. By the way, if I would come over here, and here is the student method, and you can use the one out of lesson 6 if you want. And then here's the method where you do the work, or you put the find student and you create the list and so forth. And if I run this, this is the type of output I'm expecting. There is no student with name Adam, and if you found a student, then you print out student name : Mary. And exactly how you format this is not critical. You can put out student name : Adam not found or something if you like, whatever. But this is where you get a optional is empty back, and here you get an optional with a student inside of it that you have to get out. Okay, questions about those 3 problems that I can answer? Hearing none, I'm going to go over a couple points, 6 to be exact. I want to remind you that you get 2 attempts on each quiz, and I don't assess late points on quiz. If your quiz is done before the due date, it's graded automatically by Blackboard and the grade posted. If you do the quiz after the due date and time, it puts it in the list of things to be graded. But I just accept them the way they are and don't assess any late points. Assignments, you get 3 attempts at each assignment, and late points are assessed. That's probably not spelled right. Yep. And this semester I'm being a little generous. I'm giving you a 1-day grace period. So if you turn in lesson 5 today, then there will be no late points assessed, even though it was due last night. But I would encourage you to turn in an assignment early in the week so that I can grade your first attempt and provide you some feedback. And then you still have time to fix what I say is not right, and you resubmit it again, and you get the highest grade of the 3 attempts. But if you wait until the last moment to submit, and I say, okay, well, that's not right, then you only made a 60, now you can come back and submit it late, but you get late points on the submission 2 and 3. But that still may be better than the first grade. That you just have to see. And on late points, all of the assignments this semester are the same. They're 50 points. You lose 5 points for being late within the first week with a 1-day grace period. When it's over a week late, you get 10 points off, which 10 points out of 50 is saying you can't make above an 80, even though it's perfect. Okay? And here's another one I want to remind. Do not submit an assignment that does not compile and run, because it's just a wasted submission and you will get a 0. And what you do is, if you have problems getting it to compile and or run, email me with the zip file attached. Don't submit it. Send it to me in an email and or request a teleconference. Okay? And the next one is very important. Please note, do not interrupt me during a Cowboy game.
I'm sorry.
Sorry.
I was available all afternoon, and I helped a couple students out, and then the game starts, and I probably ended up helping 3 people during and at halftime and after the game last night. And after the game, I was not very happy with the outcome. So, but anyway, And if you don't know when the Cowboy game is, if you got an iPhone, just ask Siri, what time is the Cowboy game, and she can tell you. And the last thing is Monday evening and Saturday morning sessions will continue throughout the semester with a couple of exceptions. And one will be October 27th when I will be in Amarillo. And it just so happens that I believe that week we are, see, that's the, excuse me, lesson 9. We're going to do 2 weeks on lesson 9. And so that first Saturday is not the end of the submission period. November 4th is. So we will have a session on October 22nd to introduce this information, and then we'll have the final session on November 4th. So the Saturday that I'm in Amarillo, there will not be a session. And I may hold a session on the 29th and for people to ask questions, etc. But that's that's the only date that I know I will not be able to meet. I think though maybe along in here sometime is Thanksgiving, and I'm going to Nashville the Saturday before Thanksgiving. So I don't know whether that's it's probably the 18th. I may or may not be available for the 18th. Well, I'll have to see because I may be flying. If I leave later in the day, then maybe I can get the session in the morning before I go to the airport. I probably will be able to do the session from Nashville. They have Wi-Fi and in their house, and I'll be able to do the Monday night session. But I'll let you know in advance of the exceptions. But otherwise, we will do Mondays and Saturdays because that seems to work for a lot of people, and we can record it if y'all remind me to turn on the recording, and then you can go back and listen to it. And I'll post these notes in the recording after this session. So, questions?
No, thank you so much.
No, thank you.
Thank you.
All right, you're welcome. I'm trying to help you all as much as I can.
We appreciate it.
You know,
Very much.
You know, let me tell you, stick with me, and I think you'll see that, you know, we get through these hard assignments together. And, you know, if you get them in on time, you get a 50 out of 50. If you get them in a day late, you still get 50 out of 50. If you turn them in more than a day late, you may get 45 out of 50. But, you know, that's still a good grade. So, and, you know, that's certainly better than a 0. So
Yeah.
stick with me, and I will help you through these programs. And I want to stop actually coding them for you, which I've done a whole lot of.
Mm-hmm.
But you know, that doesn't mean I'm not going to stop helping you. If you have problems getting one to compile and run, you know, I'll be glad to help you with it, and I'd be glad to hold these sessions and tell you all this information. But I want you to struggle with the problem before you know, you get with me in teleconference, because I don't want to write these programs for you. I want you to try to work them yourself, and then I will help you. Is that
Great.
fair?
That's fair.
Okay. Well, and we're doing a lot of different stuff in this class. It's not the standard, as I've said, computer science, advanced Java. We're doing a lot of stuff that I think is good, practical stuff that if you get a job as a Java developer, you know, you will see some of this, you know, like struts and unit tests. Most every shop uses unit tests. If they don't, you know, there's something wrong with that shop, because they're so very good on regression testing. When you've made some changes to someone else's code, if you have a whole set of unit tests there that used to run, you just run those, and if they all pass, then you know you didn't break anything. And if a test fails, you go back and research it and figure out what you broke, and maybe the test case needs to change. But it may be just that you broke something that you didn't mean to break. But unit tests are very good for initial testing and for regression. And shops store those away just like they do their source codes. There's something called continuous integration, which we probably won't get into. But when you check things into your code into the repository, continuous integration will, you can set it up where it actually runs all the tests and provide feedback to you of you know, what is broken. Now, hopefully you've already run those tests and know that nothing's going to break. But unit testing is a very key item, and I hope to get us working with source repositories soon also. So I think that's it. If there aren't any questions, anybody need to stay on and work on chapter 5?
I'm good.
Everybody good?
Yes.
Okay, then. Good night,
All right.
all.
Good night.
Thank you
Thank
for your
you.
time. You're
Okay.
welcome.